Ever wondered how the temperature in your room stays so comfortable? It's all thanks to HVAC engineering. HVAC, which stands for heating, ventilation, and air conditioning, is a field of engineering that ensures thermal comfort and acceptable indoor air quality. It's a science that blends thermodynamics, fluid mechanics, and heat transfer to create environments that not only feel right, but are also healthy for you. It's more than just adjusting a thermostat. It's about understanding how to manipulate air and temperature to achieve perfect harmony. HVAC is a crucial part of residential structures, industrial complexes, and office buildings. Without it, we'd be at the mercy of the elements, unable to control our indoor climates. So next time you're sitting comfortably in your room, remember that there's a whole science dedicated to ensuring that comfort. Now, let's dive into some of the fundamental concepts behind HVAC engineering. To understand HVAC engineering, we first need to familiarize ourselves with some basic units and measurements. Let's start with the unit of heat, known as the British Thermal Unit or BTU. 1 BTU is the amount of energy needed to raise the temperature of 1 pound of water by 1 degree Fahrenheit. Now let's move to the concept of a ton of refrigeration. A ton of refrigeration is the energy required to freeze 1 pound of water in 24 hours or melt 1 ton of ice in the same time frame. Air volume, on the other hand, is measured differently. We use units like cubic feet per minute, CFM, cubic meter per hour, CMH, and cubic meter per second, M3/sec. CFM stands for cubic feet per minute, and it's a unit of airflow. Next, we have the standard room temperature. It's typically maintained at 24 degrees Celsius or 76 degrees Fahrenheit. Why this specific temperature, you might ask? Well, it's considered the most comfortable range for most people. We also need to mention the American Society of Heating, Refrigeration, and Air Conditioning Engineers, better known as ASHRAE. They're a professional association involved in setting standards and guidelines for HVAC systems. Finally, let's touch on conversion factors. For instance, 1 ton is equivalent to 12,000 BTU per hour and 3.516 kilowatts. To recap, we've learned about BTUs, tons of refrigeration, measurements of air volume, room temperature, ASHRAE, and conversion factors. These are all crucial components in understanding HVAC engineering. With these units and measurements in mind, we can now delve into more advanced concepts. Now that we're familiar with the basics, let's move on to some of the more advanced concepts in HVAC engineering. First off, let's tackle the CFM formula. CFM, or cubic feet per minute, is a measurement of airflow. It's calculated by multiplying the velocity, generally around 1500, by the area in square feet. That's the diameter divided by 2 squared times pi, and then divided by 144. Next, let's talk conversion factors. In HVAC, we often need to convert between units such as tons, BTUs per hour, and kilowatts. Here's a quick guide. 1 ton is equivalent to 12,000 BTUs per hour, and also to 3.516 kilowatts. Moving on, we come to the heat transfer coefficient and thermal conductivity. The heat transfer coefficient, denoted by U, is a measure of the rate at which heat is transferred through a material. 1 BTU per hour, per square foot, per degree Fahrenheit is equal to 5.6782 watts per square meter, per degree Celsius. On the other hand, thermal conductivity, represented by K, is a measure of a material's ability to conduct heat. 1 BTU per hour, per foot, per degree Fahrenheit equates to 1.73 watts per meter, per degree Celsius. Finally, let's discuss the aspect ratio. In the context of duct design, the aspect ratio is the ratio between the height and length of the duct. The typical aspect ratio is 1:2, but it can vary up to 1:4. This ratio is crucial as it impacts the efficiency of airflow and therefore the overall performance of the HVAC system. Understanding these concepts helps us appreciate the complexity and sophistication of HVAC engineering. In just a few minutes, we've covered the basics of HVAC engineering. It's a complex field that requires a deep understanding of a variety of concepts and principles. But by breaking it down into bite-sized pieces, we've managed to tackle the essentials. Let's take a moment now to summarize what we've learned. We started our journey by understanding the fundamental units and measurements in HVAC. We learned that the unit of heat is the British Thermal Unit, or BTU. This unit measures the amount of energy needed to raise the temperature of 1 pound of water by 1 degree Fahrenheit. It's a fundamental unit in HVAC and is used in a variety of calculations and measurements. We also learned about the concept of a ton of refrigeration. This is the amount of energy required to freeze 1 pound of water in 24 hours or to melt 1 ton of ice in the same time frame. It's a unit that helps us understand the capacity of cooling systems and how much energy they require to operate. Another important concept we discussed was the volume of air measurement. This is measured in terms of cubic feet per minute, CFM, cubic meter per hour, CMH, and cubic meter per second, M3/sec. These units give us a clear understanding of how much air is moving through our HVAC systems and how effective they are at circulating air throughout a space. We then dived into the world of ASHRAE, the American Society of Heating, Refrigeration, and Air Conditioning Engineers. This organization sets the standards and guidelines for HVAC engineering and is a crucial resource for anyone working in the field. The concept of room temperature was also discussed. Typically, room temperature is maintained at 24 degrees Celsius or 76 degrees Fahrenheit. Achieving and maintaining this temperature is one of the primary goals of any HVAC system. We also learned about the CFM formula, which is used to calculate the volume of air moving through a duct. The formula is CFM equals the product of velocity, usually 1500, and the area in square feet. This formula is crucial for designing effective ductwork and ensuring that air is evenly distributed throughout a space. Next, we discussed the conversion factors used in HVAC. 1 ton is equivalent to 12,000 BTU HR and 3.516 kilowatts. These conversion factors are used to translate between different units of measurement and are essential for accurate calculations and designs. We then delved into the concepts of heat transfer coefficient and thermal conductivity. The heat transfer coefficient, U, is 1 BTU HR askew F to F, equal sign 1.73 Watt M Kelvin. These concepts help us understand how heat moves through materials and how to design systems that effectively control this heat movement. We also touched on the concept of the aspect ratio. This is the ratio between the height and length of the duct, typically taken as 1, 2, but can vary up to 1, 4. The aspect ratio is crucial for designing ductwork that effectively moves air through a space. In our advanced concepts section, we delve deeper into the intricacies of HVAC engineering. We discuss the principles of heat transfer, thermodynamics, and fluid dynamics, and how these principles apply to the design and operation of HVAC systems. Throughout our discussion, we emphasized the importance of understanding these concepts and principles, not just for passing exams or impressing colleagues, but for designing and maintaining efficient, effective, and sustainable HVAC systems. It's easy to take for granted the comfort provided by well-designed HVAC systems, but behind that comfort is a world of complex calculations, principles, and concepts. It's a world that's constantly evolving, with new technologies and approaches being developed all the time. So as we conclude this video, remember that HVAC engineering is not just about heating and cooling. It's about creating comfortable and healthy environments. It's about energy efficiency and sustainability. It's about applying scientific principles to solve real-world problems. And it's about constant learning and growth. Next time you enjoy a comfortable room temperature, remember the intricate engineering that makes it possible.